Welcome all. My name is Suresh, lecturer in ECE from Government Polytechnic, Bellampalli. I am teaching the subject Microcontroller Programming, that is in the C18 curriculum of Electronics and Instrumentation Engineering branch, 4th semester. The subject code is 402. Till now, we have learnt about the basics of 8051 microcontroller, that is the features and the functional block diagram of 8051 and the register structure of 8051. Different types of registers: general purpose, special purpose registers and special function registers, SFRs. In the yesterday's video lesson, we have completed the SFRs topic and moved on to the pin diagram. Important topic in the first chapter, that is the pin diagram of 8051 and explaining the each and every pin of 8051. And next we have seen the simplified, that is categorization of 8051 pins, and we have moved on to the next topic, that is internal memory organization in 8051. I hope you have drawn this tree diagram, that is the memory organization in 8051. It is we have internal memory or on-chip memory of data memory, that is RAM of 128 bytes and ROM of 4 kilobytes, and the external memory or the off-chip OFF off-chip memory, that is the data memory RAM of 64 kilobytes and program memory, that is ROM, it is also 64 kilobytes. And we have seen this introductory part in the yesterday's video lesson itself. The internal memory or on-chip memory, 8051 has 128 bytes of RAM for data memory and 4 kilobytes of ROM for core memory inside the IC chip. These memories are called internal memory or on-chip memory. Now see the internal RAM, or simply we call it as IRAM. Figure shows the organization of internal RAM. The 128 bytes of internal RAM with address space from 00H to 7FH is divided into 3 groups. See, we have the internal memory of 128 bytes. 002, what is the hexadecimal equivalent of 127 actually? 128 means 80 will suffice. 80 will be the equivalent of hexadecimal number, that is 80. Sorry, 128 means 16 into 8, so 80 is the equivalent number of 128, but we are considering from the 00 memory location from the starting 00H. So we have from 00 to 127 only, 127. So 80 minus 1, we have 7FH. That is the address range of internal memory IRAM 00H to 7FH. And this particular portion, this particular 128 bytes of internal memory, internal RAM memory, is divided into 3 groups or 3 parts. Now please draw this memory allocation or memory grouping. I will give you 2 minutes to draw. Please draw it. Everyone please draw it. I hope everyone has drawn this internal RAM diagram. Now observe the diagram, observe the RAM diagram. That is, we have in the lower portion, that is the starting address 00H from 0H0H to 7 up. To the left side we have, you can see that 0H to 7 up, and to the right side we have 0 to 127, that is the equivalent decimal number of this hexadecimal numbers 00 to 7 up. And in the middle portion you can see the divided RAM, the grouping of RAM memory locations. Bank 0, bank 1, bank 2 and bank 3. The bank 0 also we have R0 to R7. Bank 0, bank 1, bank 2, bank 3 from R0 to R7. And after that we have bit addressable area, and then after that we have general purpose area. The bank 0, if you see the bank 0 address, that is from 00 to 07H. In the previous video lessons, when we are learning the topic, that is the register structure of 8051, the first type of registers, that is general purpose registers, we have accumulator and B register along with this register banks. There will be 4 banks, and these banks will be selected depending on the bank selection registers RS0 and RS1 registers. By default, you can select bank 0, and there will be 8 registers in this each and every bank, and 8 for each and every register we have a separate address. So R0 will be having 00, R1 will be having 01, that is in the bank 0. I'm talking about the bank 0. 00 address is given to the R0 register, 01 address is given to the R1, like that. After 07 we have R7 register. Then afterwards bank 1. Bank 1 will also have 8 registers, that is R0 to R7, and the address is from 08. After 07 will be 08 to 0FH. 0 means 15. So 8 to 15 we have 8 addresses assigned to this each and every register of bank 1. Like that, bank 2 will also have 102, 17H, and bank 3 having 18H to 1FH. Then afterwards, if you see the bit addressable area range 20 to 2FH, 20 to 2FH. What is the range? If you see in the decimal numbers, 2F minus 20, that means we can say some F, that means 15. 0 to 15 means we have 16 addresses. 16 memory locations, 16 RAM memory locations are assigned to this bit addressable area. Then afterwards we have 30 to 7F, the remaining portion. 7F minus 30, we have 4F. 4F are considered 50. 16 into 5, that is 80. So 80 memory locations are assigned to general purpose area. So in the total we have 80 plus this 16 and again this 32. Totally 128 bytes of memory locations. That is the total RAM is assigned and given divided into these three groups. Working registers, that is 32 registers, that is the R0 to R7 of each and every bank. The lower 32 bytes address from 00 to 1FH of the internal RAM form the 4 banks of 8 registers each. The 4 register banks are numbered 0 to 3. That means bank 0, bank 1, bank 2 and bank 3. Each bank is made up of 8 registers named R0 to 7. Only one register bank can be accessed by 8051 at a time. Default bank, that is on reset, that is bank 0, 002 07 reset for bank 0. The bits RS1 and RS0, that is PSW point, PSW, that is program status word register. We have already learnt about these registers and I have seen this RS0 and RS1 banks, RS1 selection bits for the bank selection. PSW, program status word, are used to select any one of the 4 register banks. Next portion is bit addressable area. 8051 provides 16 bytes of a bit addressable area. That means from 20 to 2FH. It occupies RAM byte addresses from 20 to 2FH, forming a total of 128 addressable bits. 16 bytes of memory location, that is totally it is bit addressable, so we can calculate in number of bits also. So the 16 into 8, it is 128 bit addressable. Next is general purpose area. The last 80 bits, that is 30278 of 8051 internal RAM, is called the general purpose RAM or scratch pad memory location. So the general purpose RAM is also called scratch pad memory location. See, this is a question asked in a mock ESET, that is online. If you want to write the mock online ESET exam in the official site, that is ESET, government ESET site, where you want to apply the ESET, in that you can see that is mock test can be written for each and every branch. You select the instrumentation branch or ECE branch, and then you can find a model paper. In the model paper, this question is there: what is the range or what is the size of the scratch pad memory? They didn't ask the general purpose RAM. The question is like this: what is the size of the scratch pad memory in 8051? This was the question asked in that model paper, which can even come in the ESET or in the, and if you go to the higher education, then you can find in the grade paper also. See, such type of questions are tricky. We will remember the first name, that is the general purpose RAM. Everybody can remember, everybody will remember that name. But the scratch pad memory, that is the name we have to name by. These are the questions asked. Yes, you can find the mock test paper in the online, and you can see the number of questions. This question is there. The scratchpad area is used for general purpose storage, that is to store data, result, constants and intermediate result. For general purpose we will use 6 type of memory, and the range, so that is the 80, that is 330278. Now the IROM, internal ROM, this figure is for 61 kilobytes, don't read it now. Now see the IROM, internal ROM. We have till now we have learned about the internal RAM, that is 128 bytes divided into 3 groups. First lower portion 32 bytes are for register banks, and in the next part is bit addressable area of 16 bytes, and after that 80 bytes of general purpose area. Now moving on to the internal ROM. The internal ROM is 4 kilobytes. 8051 has 4 kilobytes of internal ROM with address space from 0000 to 0FFH. How to calculate this address range? 4 kilobytes. 4 means 2 square, we can write, and kilo means 2 power 10. Kilo means 2 power 10 bytes, remainder byte portion. So 2 square into 2 power 10, 2 power 12, 2 power 12. So the 12 ones, if you write the 12 ones, 11, 11, 11, 11, 11, 11, and equivalent hexadecimal byte. If you write the equivalent hexadecimal directly from binary to hexadecimal by taking the 4 bits at a time. Are you following? Right? 2 power 4 kilobytes means 2 square into 2 power 10. That means 2 power 2 power 2 plus 10, that is 2 power 12. The 12 ones, you have write 12 ones, binary ones, 11, 11, 11, 11, 11, 11. And we need to take 4 bits at a time for converting the equivalent hexadecimal from the binary directly. Directly from the binary we can convert to hexadecimal. So it is 1111 and so the remaining ones. So the 1111 represents F15. So 4 ones means 1, again 4 ones F, and again 4 ones F. So triple F is the equivalent hexadecimal number for the binary, and the range is from 0 to 0 triple F, 0 0 0 0 4 zeros to 0 triple F. So that is the range of a 4 kilobytes internal ROM. This is used to store final version of the program codes, hence the name program memory. So it is used to store the program memory. That's why it's called program memory. Note, it is programmed by manufacturer when the chip is built. When the 8051 microcontroller chip is built in the laboratory, then itself it is programmed by the manufacturer. This part cannot be erased or altered after fabrication. This after the completion of this 8051 chip making, then we cannot erase that and alter that portion. Actually, this should be 0 to 0 triple F, that is 4 kilobytes of internal ROM should be the diagram. The 64 kilobytes for external RAM or external RAM is same, so because the range is same for 64 kilobytes RAM or ROM external. 64 means 2 power 6 into 2 power 10. 2 power 6 represents 64 and kilo means 2 power 10. So both will be 2 power 16. So number of ones will be 16. So we will get an extra F. Beside triple F, we get an extra F, that is 4F. So 000H to double F H is the range of the 64 kilobytes RAM or ROM external. So that is the memory, internal memory arrangement. Topic is the internal memory organization, right? That's why we have learned only about the internal memory. Now moving on to the next topic, interrupts. Next topic is interrupts. First is the definition. An interrupt is a signal from hardware or from a program that interrupts the normal processing of the CPU. Normal means generally it is doing its work. Some calculations, some mathematics, some data processing operation, CPU is doing. In the meantime, if there is a signal, from the hardware or from the program that interrupts the working of CPU. Anything that interrupts is called an interrupt. So upon receiving an interrupt signal, the microcontroller interrupts the whatever it is doing and serves the device, serves the interrupt. That is called interrupt service routine. It's a software, ISR, interrupt service routine. That means it's a software written to handle that situation, handle that interrupt. So in the previous video lessons, that is during the first chapter introduction part, we see the features of 8051. We have 5 interrupts. 5 interrupts in the 2 are external interrupts and 3 are internal. In the 3 internal interrupts also, 2 are from the timer interrupts and 1 is from serial port interrupt. Remember, right? So reading the third point, the program associated with the interrupt is called interrupt service routine or ISR or interrupt handler, interrupt handling thing. When an interrupt is invoked, the microcontroller runs the interrupt service routine. Invoked means when it is detected. When it is detected by the CPU, it will call the ISR, interrupt service routine program, and it will serve the interrupt. After it is serving the interrupt, then it will be going back to do its normal, whatever the work it is assigned before the interrupt has occurred, it will continue its work. The CPU will continue its work. So this is the part 8051 provides 5 interrupts. 2 interrupts are external and remaining 3 are internal interrupts. External are INT 0 and INT 1. Internal are timer 0, timer 1 and serial communication. Types of interrupts. If you see this diagram represents the slide only. You no need to draw this. If you want to draw it, I will give you 1 minute to draw. Please draw it so we have a clear picture. Please draw, everyone, interrupt structure of 8051. I hope everyone has drawn this diagram. Now just look at this diagram. Internal interrupts of 8051. External interrupts INT 0 bar, INT 1 bar. internal interrupts, timer interrupts, and serial port interrupts TF0 and TF1, serial port that is RI or TI. Now the external interrupts are provided by the external circuitry connected between the pins INT0 bar and INT1 bar of the 8051. The external interrupts are provided by the external circuitry connected between the pins INT0 bar and INT1 bar of the 8051. Memory locations 0003H and 0013H in the interrupt vector table are assigned to INT0 bar and INT1 bar respectively. Yes, there will be particular vector addresses are assigned to this interrupts. You can see in the table, the INT0 bar is assigned with 0003H and INT1 bar is 0013H. Internal interrupts in the timer interrupts. Two interrupts are set aside for the timers, that is one for timer 0 and one for timer 1. Timer 0 and timer 1 interrupts are generated by TF0 and TF1 in their respective timer or counter registers, and we have already seen this timer or counter registers, the TF0 and TF1 bits. If you remember, or we can memorize those parts. So those interrupts are generated by TF0 and TF1 in their respective registers. Memory locations 000BH and 001BH in the interrupt table belong to timer 0 and timer 1 respectively. Serial port interrupt. Serial communication has a single interrupt that belongs to both receive and transmit, RI or TI. In the previous slide we have seen that RI or TI. Serial communication has a single interrupt that belongs to both receive and transmit. The serial port interrupt is generated by the logic OR of RI and TI. Logical OR of RI and TI. That is, if any one of these RI and TI is highlighted or activated, then we get in the output, that is logical OR operation, right? If any of the input is high, then we get a high output at the high output at the output of OR logic gate or OR logic. So the interrupt vector table location is 0023H, which belongs to this interrupt. That is, serial port interrupt has 0023H. Now the vector address and the priorities of the interrupts. Each interrupt has its own program known as ISR, interrupt service routine, which was stored from a predetermined location. So the location address is this vector address. All the interrupts of 8051 are vectored interrupts. Vector means if there is an address assigned to this particular interrupts, they are called vector interrupts. If there is no address is assigned, then it's called non-vector. That means when an interrupt occurs, the control of microcontroller is automatically transferred through its service subroutines, that is ISR. When the interrupt is occur, a microcontroller will detect whether an interrupt is occurred or not, or whether it is serviceable or not, and whether it has the highest priority if there is simultaneous interrupt. And after the detection, if it wants to service that interrupt, if there is a vector address, then the control of the microcontroller will be start executing from the vector address of this interrupt. So it no need to search for the ISR, then it will be automatically stored in the program code. So it will be transferred to that particular address and it start executing, that is servicing that interrupt. There are 5 vector addresses for 5 interrupts fixed by the manufacturer. And this is the table. If more than one interrupts are occurred simultaneously, the microcontroller will service the interrupts according to their priority. So which one has the highest priority, it will be served first. If there is simultaneous occurrence of priorities, occurrence of interrupts, the vector address and the priorities, of the interrupts of 8051 are listed in the table. See the interrupts, we have external interrupt 0, int 0 bar, timer 0 interrupt, tf 0, external interrupt 1, int 1 bar, and timer 1 interrupt tf 1, serial port interrupt ri or ti. That is in the parenthesis the pins or the bits of that particular interrupts. In the previous lectures, previous tables, we have seen ext0, ext1, like that, right? It's just the names. See the vector address. First see the priority, and we have already discussed this priority in the IP register topic. Highest to lowest. Highest is the for external interrupt 0, and lowest is for serial port interrupt. That is the priority decreases from top to bottom. The vector address, starting vector address of external interrupt 0 is 0003H, and then for timer 0 is BH, 13H, 1BH, 23H. If you see the difference between these vector addresses, that is B minus 3, you will get 8. 13 minus B also, you will get 8. 8, is that correct? B means 10, no, it is 11. 11 minus 3, you have 8. 13 means how much? 3 plus 8. 3 plus 16, 3 plus 8, no, it's not 8, it is 16. So 3 plus 16, you have 19. 19 minus B means 11. 19 minus 11, you have 8. Again 1B minus 1 3, difference is 8. 2 3 minus 1B, you have 8. So that if you remember only one address, one vector address, that is the starting vector address, if you remember int 0 bar, it is 3H. Then by adding 8 to this vector address, you can get the remaining vector address. Yes, that is important. Why am I teaching that topic, teaching that tip to you? Because in the exam, and maybe in the diploma exams or in the competitive exams also, you can get this such type of questions. What is the vector address of this timer 1 interrupt in 8051? You can give the options, then you need to select. So which interrupt will have the highest priority, or which interrupt has the lowest priority? Yes, any questions you can expect in the exam. So you need to have some tips to easily recollect the registers and their addresses and interrupts also. So in the note section, for example, if int 0 and tf1 are activated at a time, then the 801 will respond to int 0 initially, as it has higher priority than the tf1. int 0 means external interrupt 0, that is the first one, that is the highest priority, and tf1 is the timer 1 interrupt, but it has the next to the lowest. So if both are activated at a time, that means both are activated simultaneously, then the int 0 will initially have the higher priority, and it will be serviced first. The priorities of the interrupts can also be altered by programming the IP register. Yes, in the interrupt priority register, if you can remember, the priorities of these registers can be altered. The external interrupts can be programmed to be either level active or transition activated by setting or clearing the bit IT1 or IT0 in register TCON. In the TCON register we have these bits IT0 and IT1. They can be programmed to either level active or transition activated. Level active means the pulse. We are giving the clock, right? The clock we have the transition from 0 to 1 or 1 to 0, and the levels will be there. That is 0 level and high level, 1 level. So the interrupts we can make by assigning these bits to active level, level active or transition activated. That they can be occurred at the transition of 1 to 0 or 0 to 1 or level active, that is either higher level 1 or lower level 0. All the interrupts of 8051 are maskable interrupts. They can be masked. It means that all the interrupts of 8051 can be individually enabled or disabled by setting or clearing a bit in IE interrupt enable SFR. We have already discussed this register in the previous video lessons. IE register, interrupt enable register. These are can be masked interrupts, maskable. The IE register contains also an interrupt disable bit EA. Disable or enable EA bit, which disables all interrupts when it is 0. In order to handle 5 interrupts, the 8051 use SFRs such as IE, IP and TCON. So to handle these registers interrupt, in order to handle these interrupts, 8051 has SFRs, that is special function registers, interrupt IE, IP and TCON. I think with this we have concluded the first chapter. We have completed the first chapter. Just to recap the entire chapter because we have only less than 7 minutes. It's not the entire chapter. From the SFRs only this slides. The SFRs TMOD register, timeout mode register, TCON, timer control, IE interrupt enable register, enable or disables all or any of the registers. IP interrupt priority register, use it to alter the priority. And SCON, PCON power control register used to control the baud clock generator. SBUF is physically 2 registers, one is for write only and another one is read only, that is TXT and RXT. And ports, we have discussed many times these ports, IO ports and their special functions, and the special function registers assigned to this particular section, particular type of registers, that is interrupts control registers, that is II and IP, and timer 0 registers TL0 and TH0, timer 1 TL1 TH1, timer are count control SFRs TMOD and TCON, serial port SFRs SCON, SBUF, PCON, and parallel IO ports P0 to P3. And we have discussed each and every registers in detail, right? The IP register, IP SFR and IE register, 8-bit register, higher priority or lower priority one, bit 0 for lower priority, if it is bit 1 we have higher priority. Bit addressing is allowed. In the register pattern we have seen each and every SFR's bit arrangement in detail with the table like this, that is which bit is for which functioning and a symbol, remember, right? And in the priority bit set to 1 and high bit address interrupt priority, look at this. In the previous table we have mentioned only the name, external interrupt 0 and timer interrupt 0. We didn't mention even the pins also. And I register interrupt enable SFR 8-bit enables or disables, bit 0 for disable, bit 1 for enabling. So maskable, not just disabled, masked. In the fourth point, the last but one point, upon reset all interrupts are masked, that means disabled. This is the bit pattern, bit and symbols, the function, what it will do, function with the particular interrupt also. And we have next moved on to the timer SFRs TL0 TH0 timer 0 lower byte, because timers and counters are 16-bit registers, and the 8051 is a 8-bit microcontroller to arrange and to did not function malfunction. It has to be properly arranged. The bit pattern should be properly arranged and matched with the 8051. It is the accumulator register. Most important one is the accumulator register. So with that 8 bits, the 16-bit timers and counters are divided into two registers, TL0 TL1 and TH0 TH1. And again the control SFS T mod to select the modes of these timers. So there will be 4 modes of these timers, and each and every bit pattern there is the gate control, timer or counter selection, and the mode selection bits, particularly M1 and M0 for operating mode. Mode 0 is a 13-bit timer, and mode 1 is a 16-bit timer, and mode 2 is 8-bit auto reload function, and mode 3 split mode, only the TL0 T timer 0 will be used. Again TCON register timer control SFRs. The lower nibble is assigned for interrupt control bits, and the higher nibble is for timer 0 timer 1 control bits. We have seen all this bit pattern: overflow flag, run control, interrupt 1 flag. So that was the end of the August 3rd. And next we have, in the next lesson we have discussed the serial port SFRs: SCON, SBUF and PCON. Serial control, again the bit pattern: SM0, SM1, serial port mode control, bit 1, bit 2 and bit 3, or bit 2 also there, bit 0, 1, 2, TV8, RB8, TI and RI. Transmit interrupt flag and receive interrupt flag. No two flags at a time, only one flag is activated, that is only one interrupt is activated. And SBUF, serial data buffer. So we have discussed about SBUF also, and PCON SFR, PCON's bit pattern. Now the parallel IO ports, in detail we have discussed about this parallel IO ports: port 0 IO port, port 1 IO port, and port 3 has some special functions, that is RxD, serial data input, serial data output, external interrupt 0 and 1, timer interrupts read and write. Additional, that is the bit particular address of this SFRs. All SFRs address is given here. Accumulator is a general purpose register. It's not an SFR, but it is the registered address. You can call it as a register address of each and every register. That is accumulator register: B register, PSW, SP, DPL, DPH, P0, P1, interrupt priority. The star mark indicates they are all bit addressable. So next we have discussed about the pin diagram, most important topic. You have drawn this pin diagram in detail. I told you to practice it without looking at the diagram. You must draw at least 3 times, so then only you can remember that if there is 40 bits and each and every pin, you can remember each and every function also. If you remember the diagram, you can write theory, right? So that is the practicing. You can have it for the external exams also. And we have discussed the each and every pin and their functions. Some special functions are multiplexing signals, address AD0 to AD7 and A8 to A15, categorization of pins, crystal pins, and external 8 pins with this 32 IO pins. And next we have moved on to the memory organization. That is today's topics: internal memory, that is RAM of 128 bits, how it is divided, that means the 3 groups: register banks and bit addressable area, then followed by general purpose area. Again program memory of 4 kilobytes. Next we have seen about the interrupts, that is how the interrupt priority is there and what is the vector address the tree diagram of classification of interrupts, serial port interrupts, what is known by vector address, what is an ISR, interrupt service routine, what the processor will do when an interrupt is invoked. So like that we have discussed these topics, and if you have any doubts regarding this first chapter, you can mail me at sureshakul2001@gmail.com. Now with this I am closing today's video lesson. Please read the entire chapter 1 once before we are discussing, you are watching the next video lesson, that is the chapter 2. Okay, because these all chapters are interconnected. The 8051 basics, only the physical structure we have seen, that is what are the options available in this 051. We have seen only that, we have learnt about them only. Now see the software part, what is the software version, that means how we have to write the program. So all we can discuss in the coming lectures. With this I am closing today's lesson. Thank you one and all.